This is Advanced Algebra, Unit 6, Day 9 notes. So in Day 9, we're doing some review here. We're going to start off with solving by factoring here. So when I'm looking at this, I see an x squared and x. I move the 56 over to make it equal 0. I looked and see if I can factor it. Yeah, I can factor it. X minus 8, x plus 7, multiplies to negative 56, adds to negative 1. We solve it from there. In 2, I'm looking at this. First things I see, I can take a 2 out. I can also have I have an x cubed and x squared and x. So I think I'm going to take out a 2x there. When I factor it out, I have x squared minus 11x plus 10 left. At this point, I look inside. Can I factor the inside? I'm going to try. I know it's x squared, so it's x and x here. I look at my last term, which is positive 10. So that means it's going to be positive, positive, or negative, negative. On the inside, it's negative 11, so I think it's negative, negative. And that's where I get the 10 and 1 from. I have 3 things multiplied to be 0, so I set each of them equal to 0. 2x equals 0, x minus 10 equals 0, and x minus 1 equals 0. So when I solve it, I get x equals 1, x equals 10, and x equals 0. Notice as x to the third, I end up with 3 real solutions. Looking at number 3, first thing I notice I have n's in all of them, so it looks like I'm going to take out an n. I'm also going to move the 23n squared over. So I get 6n cubed minus 23n plus 7n. Now looking forward, after I take out the n, I'm going to try to factor it here. Now I have the 6 there, so that could be 6 and 1 or 2 and 3 here. But I'm going to look at the last number, which is a 7. Nice thing about a 7, it's prime, so it only can be a 1 and a 7. So I'm going to kind of work this backwards. Instead of putting the first ones in, the n squared, I'm going to look at the 7 here. Now it's a positive 7 and a negative 23 in the middle. So I know it's going to be negative 7 and negative 1. At this point, now it's just, is it 2 and 3 or is it 6 and 1? If I did 6 and 1, I'd get 6 and 7 as 42. No, that's too much. Or 6 and 1 and 7 and 1. No, that doesn't work. So I think I'm going to try 3 and 2 here. Well, 7 and 3 is negative 21. 2 and negative 1 is negative 2. So I think that's negative 23. That works. I have 3 things multiplied to be 0, so one of them has to be 0. I get n is 0, n is 7 halves, and n is 1/3. And then the last thing here on the warm-up. What are the 4 algebraic methods to solve quadratic equations? So we have the first one, take the square root, right? That's what we always look for. Is there a single x? Then we look, can I factor it? If I can't factor it, the next thing to solve it I would probably go to would be the quadratic formula. And then finally, we also have completing the square. That's where we got the quadratic formula from. So we're going to take a look today and remind ourselves, okay, what's the most efficient way to solve some of these here? So first thing I see, there's a single x term there. So I'm going to get the x squared alone. I'm going to take the square root. I get x squared equals 16. To get rid of the squared, I take the square root. I always have to remember when I introduce the square root, plus or minus. So I should get x equals plus or minus 4. 2 answers, x squared. 2 real answers. So in the next one, I see an x squared and an x. I'm not going to be able to just take the square root. So the next thing, can I factor it? I move it over. X squared minus 6x plus 13 equals 0. Now 13, prime, 1 and 13. Well, I don't think there's any way I'm going to get to negative 6 from 1 and 13 here. So if I can't factor it, my next step, Well, looks like I'm going to have to use the quadratic formula. I could complete the square, but again, for me, I think quadratic formula is a little bit quicker, a little bit easier. If you wanted to complete the square in this one, I have that 6 there as my b. You could do that. That'd be okay. Opposite of b, plus or minus the square root of b squared, minus 4ac all over 2a here. The opposite of negative 6 is just 6 here. Plus or minus the square root of 36. And then I look here. I have a negative 4, a positive 1, and a positive 13. So I think it's going to be a subtraction, right? Because, yeah, negative 52 is here. So I have 36 minus 52 all over 2. 6 plus or minus the square root of negative 16 all over 2. I look and I see, oh, the square root of a negative. I know the answers are non-real. I can still figure them out. The square root of negative 16, remember we broke that up into the square root of 16, square root of negative 1. That's 4i. And it's all over 2. So now I can split them up if I wanted to. 6 over 2 plus or minus 4i over 2, which gives me my final answer of x equals 3 plus or minus 2i. The next one here, first thing I see again, x squared and x. All right, can't just take the square root. Next thing, can I factor it? Now this one has a 2 out in front here, so I'm going to have to try some different options here. However, I don't think I can factor it. 2, 6, and 1, 2, and 3, no. So, next step, I do the quadratic formula. Notice when I'm putting in, I put things in parentheses here. I'm going to write that part first. That's what I'd like to see when you do the quadratic formula here. So we get 9. Now I look, it's a negative, a positive, and a negative here. So I think it's going to be positive. So I put plus down. And then 4 and 2 and 6, that's 48. When I add it together, I get x equals 3 plus or minus the square root of 57 all over 4. At this point, I can't simplify the square root of 57, so I'm done. That's it. I could give the decimal approximation, but we're not graphing. We're not using it. It's not an answer to a word problem, so I would just leave it like that. In the next one, I see x's in all of them, so I'm going to take out an x. After I do that, I look, can I factor it? Positive 6, so I think that's going to be a negative and a negative because of the inside term. Yeah. And 6 and 1, yeah, that gives me a negative 7 when I put it together. So I get x is 0, x is 6, x is 1. Then I look, I have a single x. So when I have a single x, I can take the square root. I want to get everything away from the squared part here first. I think of my reverse steps, right? So I divided by 3. To get rid of the squared I, take the square root, plus or minus. I get x minus 7 equals plus or minus 3. When I move the 7 over, I get 7 plus or minus 3, and now I have two solutions. One where 7 is plus 3, which is 10, and one where it's 7 minus 3, which is 4 here. So the last one here, I think it's the last one. So the last one here, I think it's the last one. Yeah, look, x squared and x. I'm going to factor it, maybe complete the square, maybe quadratic. I look and see if I can factor it. In this case, yes, I can. 2x and x. It's a positive 2 and a negative 5, so it's going to be minus minus. And I want 2 and 2 is 4, negative 1 and x is negative 1x, so I get negative 5x. I have two things multiplied to be 0, so I set both of them equal to 0. And I get x is 1/2, and x is 2. So that brings us to our closure here. The methods that we talked about here. State each method, when's it most appropriate to use when solving quadratic. So the first one we always look at, take the square root. Right? When do I do that? When I have a single x in the equation. If I can't take the square root, I look to factor it. Do I have multiple x's? An x squared and an x. And is it factorable? If it's not factorable, the next thing I would do, I would go to the quadratic equation. Okay? Actually, I should say the quadratic formula here. So the quadratic formula, right? And then if I don't want to do that, I could complete the square if I'm bored. Now, there are times that maybe completing the square is easier, and that's fine. You could use that as well instead of the quadratic formula.